Hello. This video today is on section 9.2, measuring angles and arcs. And it's going to be a fairly long lesson, so I'm going to put the entire lesson on one video today. Let's get started. Measuring angles and arcs. A central angle of a circle is an angle with a vertex in the center of the circle. Its sides contain two radii of the circle. Angle ABC is a central angle of circle B. Recall from lesson 1.4. So here's some examples of central angles. Okay, so recall from 1.4 that a degree is 1/360th of the circular rotation about a point. This leads to the following relationship. The names of the three most common trigonometric ratios are given below. Sum of central angles. The sum of the measures of the central angles of a circle with no interior points in common is 360. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 360. Example 1, find the value of x. So we've got ourselves this circle here, circle T, and we're going to find the value of x. So as you can see here, I've got a diameter going from R to V. So I've set the problem up. If I add 8x minus 4 plus 13x minus 3 plus 5x plus 5, that degree measure should equal 180. So my combining like terms, I have 8x plus 13x plus another 5x. I have 26x. Minus 4, minus 3 is minus 7. Add 5 is minus 2 is equal to 180. By adding 2 to each side, I have 26x is equal to 182. Solving for x, I divide by 26 on both sides. So my value of x is equal to 7. Example 2, find the value of x. We have ourselves a circle here with angles 115, 60, and 105. If I take x and I add 105 plus another 60 plus 115, that's going to add up to 360 degrees. So 105 plus 60 plus 115 is 280. So we have x plus 280 is equal to 360. By subtracting 280 from both sides of each side of the equation, you end up with x is equal to 80. Example 2, letter B, find the value of x. We have a circle Z here, 75 degrees, 5x minus 5 degrees, 7x plus 2 degrees. We don't know much about any of these other two angles, but we're looking for the value of x. So as you can see, we have a diameter running through here. We have AD is the diameter of circle Z. So if I add 75 plus the 5x minus 5 and the 7x plus 2, that's going to equal 180. So combining like terms, I have 12x plus 72 plus 72 is equal to 180. By subtracting 72 from both sides, you have yourselves 12x is 108. Okay, so you're at 12x is 108. By dividing by 12 on both sides of this equation, your value of x is equal to 9. So be on the lookout for these types of problems in today's work. Next up, 9.2, page 3 notes. We're going through what is called a minor arc, a major arc, and a semicircle. Okay, this is a fairly simple concept. A minor arc is the shortest arc connecting two endpoints on a circle. The measure of a minor arc is less than 180 and equal to the measure of its related central angle. So measure of arc AB is equal to the measure of angle ACB, which is equal to x. So you can see the graphic here. So the measure of arc AB is equal to the measure of angle ACB, which is equal to x. It's also noted as the measure of AB with a little arc on top. A major arc is the longest arc connecting two endpoints on a circle. The measure of a major arc is greater than 180 and equal to 360, minus the measure of the minor arc with the same endpoints. So the measure in this case of ADB is equal to 360 minus the measure of arc AB, which is equal to 360 minus x, okay? So the measure of angle ADB, it shouldn't be angle here, I'll just take that little piece out. Measure of arc ADB. So that's considered a major arc. So you want to think of that as anything that's going to be greater than 180. And lastly, on arcs and arc measures for this page, it's a semicircle. A semicircle is an arc with endpoints that lie on a diameter. So the measure of a semicircle is 180. So the measure of arc ADB, in this case, ADB is equal to 180, which is also the measure of angle ADB. Measure of arc ADB. Example 3, letter A. Segment WC is a radius of circle C. Identify X, Z, Y as a major arc, minor arc, or semicircle. Then find its measure. So WC is the radius, and we're identifying X, Z, Y. So X, Z, Y. So arc XZY happens to be a semicircle. Which is equal to the measure of arc X, Z, Y, X, Z, Y, which is equal to 180. Okay, so this next section, we have two examples. We have example 4 and example 5. Basically, what we're going to do, start with example 4 first here. Basically, this gives us a circle, in this case, circle R. We've got some noted angles already in place. And what we're asked to do, it says here that AC and EB are diameters. So AC and EB are diameters of circle R. We're going to identify each arc as a major arc, a minor arc, or semicircle of the circle. Then we're going to find its measures, okay? So let's just first identify some of these other angles in here. This angle ARB, okay? So if we know that this is 50, and this is going to be 50 over here. And if that's a diameter, this ARB is going to be 130. Okay. So as you go around the horn, you can kind of tell this is going to be 130 here. This is going to be 50 on the outside here, this arc. This will be 100. This will be 30. And this will be 50. Okay, so let's start with measure of EA. Okay, measure of EA is a minor arc. Minor, and it's 50 degrees. Number 2, CB. CB is minor. Minor arc, it's less than 180. CB is also 50 degrees. The measure of DC. The measure of DC. DC is located right here. It is a minor arc. And it's 100. DEB. DEB is 210. You take 30 plus 50 is 80 plus 130. So DEB all the way around here is 210. And that's major. Major. It's a major arc. Number 5 on example 4, measure of arc AB. In this case, AB is 130. It's minor. And lastly, number 6, the measure of CDA. CDA is 180, and that's considered a semicircle. Semicircle. So not too tough, example 4. All right, same thing on example 5 here. You have yourself a circle here, and you got 50 degrees and 100 degrees. So AC and DB are diameters of circle Q. Identify each arc as major, minor, or semicircle of the circle, then find its measure. Okay, so this is kind of work through this. So if this is 100 here, and we know that this is 50, okay, that means that this is going to be 50. Okay, And you can see that by you've got your vertical angles here. So this 100 is equal to this 50 plus 50, okay? And if this is 50 and this is 50, we all know that this is going to be 80 because that adds up to 180. 100 plus the 80 is 180. And if that's 80, this is 80. So you're going to want to just carefully do that on every circle in your assignment today when you're asked on these arc questions. So going around the horn, this is going to be 50. This is 50. This is 80. This is 100, and this is 80. Okay, let's start with measure of angle AE. AE is 50, it's minor, and it's 50. Measure of angle ED of arc EDC. EDC is 80 plus 50, which is 130. That's also minor. Measure of ABC. ABC is here. ABC is going to be 180. That's a semicircle. Letter D, measure of AB. Measure of AB is 80, and that's also minor. Letter E, measure of ADC. Measure of ADC is a semicircle, and that's 180. Semicircle. And the last one, letter F, the measure of arc BC. Measure of arc BC is 100. And that's also minor. So be on the lookout for examples. They're not too tough, but like examples, example 4 and example 5. All right, congruent arcs. Congruent arcs are arcs in the same or congruent circles that have the same measure. So in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So if angle 1 is congruent to angle 2, then FG, arc FG is congruent to arc HJ. If arc FG is congruent to arc HJ, then angle 1 is congruent to angle 2. Adjacent arcs are arcs in a circle that have exactly one point in common. In circle M, HJ and JK are adjacent arcs. As with adjacent angles, you can add the measures of adjacent arcs. This brings us to the arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. The measure of arc XYZ is equal to the measure of arc XY plus the measure of YZ. Arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of two arcs. Okay, which we just covered. Let's go through example 6. Okay, FH and EG are diameters of circle P. Find each measure. All right, so let's take a look at our circle here. We have 90 here, so I could fill that in, 90 here. And I've got a 38, okay? So since this is a diameter, EG, it's told us it's a diameter, so we have 90 and 38. So this is gonna put this at 52 degrees. Because if you add the 90 and the 38, and subtract from 180, you get your 52 degrees. Okay, so 52 degrees is here, and 52 is the arc. All right, so I'm going to fill in the 52 here. This little bit smaller circle. I'll switch my pen. All right, now if this is 52, this is 90, and this is 38, I'll put 38 on the outside here. So if this is 38, we're going to know that this EPF is also 38. Okay, and that arc is going to be 38. And if that's the case, if this is 38 and this is the diameter, this FPG is 142. 142. So I've got my circle kind of all labeled. Let's take a look at the problem. Let's find the measure of arc EF. All right, so you got EF is 38. Measure of FG. FG 142. Measure of DFG. DFG. So we got to go 52 plus 38 plus 142. DFG is 232. The measure of DE. DE is 52. The measure of DHG. The measure of DHG is 38 and 90, which is 128. And the measure of DGE. DG all the way around to E, we're going to take 360 and we're going to subtract 52 and you get 308. 308, measure of those arcs. Example 7. Segment PR and segment QT are diameters of circle A. Find each measure. Okay, let's go around and figure this all out, okay? So I've got myself 40, 50, and 40. Okay, so we can start chiseling at this. If this is 40 and 50, it's 90. You know what, this is going to be 50 here because this is a diameter, okay? So this is going to be 50 in here. And then this arc is 50. 50 degrees out there. So this is going to be 40, this arc. This arc is going to be 50. Okay, and this is 90 here. So this arc is 90. And if this is a diameter here, this is also going to be 90. So we have everything labeled here. We can start handling these questions here for example 7. All right. So letter A, U, P, Q. All right, so find U, go to P, and then Q. That appears to be, oh, I forgot to put my 40 in here. UPQ is 90 plus 40, 130. Letter B. U T S is 90. 40 plus 50. R S U. So you've got yourself R, you got 50, S, and then all the way around, another 40, 90 plus 50. That appears to be 140. Measure of arc PQS. P, Q, all the way around, so you got 180 plus 50 is 230. Measure of arc PQR. PQR is not 180, 90 plus 90. The measure of arc RS. The measure of arc RS is 50. The measure of arc STP. STP is going to be 40 plus 50 plus another 40 is 130. And lastly, the measure of PRU. PRU is 360 minus the 40, which is equal to 320. And that's example 7. Last page today, I told you the video is going to be long. Last page for this notes. Another way to measure an arc is by its length. An arc is part of the circle, so the length of an arc is a part of the circumference. The proportion to find the arc length can be used to find the arc length in any circle. All right, arc length. So basically what this is, we're going to take the ratio of the length of an arc, L, to the circumference of the circle is equal to the ratio of the degree measure of the arc to 360. Okay, so we got this proportion set up. So we're going to take the L, the ratio of the length of an arc, L, and we're going to divide that by the circumference of this, which is 2 pi r. 2 pi r is the formula for the circumference of a circle. And we're going to set that equal to the degree measure of x divided by 360. So that's going to be our proportion. And we're going to most likely use this equation more often. Basically, it's just algebra to come up with that. So L is equal to x over 360 times 2 pi r. Okay, so if you multiply 2 pi r on this side and this side, you would end up with this length of an arc. Length of an arc, if I call it a formula, which is equal to a over 360 times 2 pi r. A over 360 times 2 pi r. Now, A is considered the central angle. Central angle. We're going to do 3 problems to finish the video today on this, on example 8. We're going to do A, B, and C. We are not going to be doing E and F, D, E, and F. Okay. Let's start by looking at the first one. This is our circle, okay? Use circle D to find the length of each arc, round to the nearest hundredth, okay? So what they're saying here is we're looking for the arc LM, this first case. We're looking for the length of arc LM if the radius is 5 inches, okay? So they're going to tell us, they're going to ask us, if the radius is 5, what would be the length of LM, okay? LM. So this is the formula. L is equal to x over 360 times 2 times pi times r. Now use pi, your pi key on your calculator for this, which is equal to 100, which is the angle. over 360 times 2 pi times 5. 5 is the radius that's given to you. And if you use that calculator work here, that ends up being 7.33 centimeters. 7.33 centimeters is the length of arc LM with radius 5. Okay, let's look at B. We're looking for the arc length of KL. Okay, so KL, and they're telling us that the radius is 7. The radius is 7. Okay, so we're going to use, first off, the measure, the angle measure of the angle that we're dealing with. And this KL, the measure is 60. We're going to divide that by 360. And then we're going to multiply times 2 times pi, and then we are told that the radius in this problem is 7. Okay, so the radius is 7. So if the radius is 7 and the degree measure of that central angle is 60, the arc length of KL is 7.3. Back up. I gave you the wrong one here. Okay. Letter A, I'm sure you would have caught that, is 8.73. And that's inches. The calculator work on B would put you at 7.33 centimeters. So the arc length of KL would be 7.33. Okay, so make your adjustments there. Last one today on this video, over the time limit. If you want to do these 3 as practice, you can. We're looking for KLM. KLM. So take a look at the circle. KLM. You can see you've got 100 degrees and 60 degrees. And they're telling us that we have a radius of 9. Okay? So our central angle is going to be 160. You've got 100, okay, plus the 60. So 160 divided by 360. And that's multiplied by 2 times pi, and then the radius for letter C is 9. And with that calculator work, it's 25.13. 25.13 millimeters. That's the entire notes for section 9.2, measuring angles and arcs. Hopefully you found this beneficial today, and I hope to see you all soon. Take care. Have a good day.